Thank you. No. Questions from last time?
Like you said in the BAM, you're having same amplitude, right? And
Same amplitude in the PAM? No, never.
same frequency.
Same frequency in the PAM? It is, but we never commented about that.
But how it's like same if we are having Wi-Fi, Bluetooth, do you have different frequencies? Same like standard frequency or what?
No. So, whenever I have Bluetooth, Wi-Fi, and so on, so once I select this band, so they tell me work on the Bluetooth, okay? So once I select on the Bluetooth, then I select the modulation for the Bluetooth, and it is PAM for the Bluetooth. So it is within the frequency of Bluetooth. So it will be fixed frequency for that user. Good. Different systems, they have different modulations. يعني I can the phone okay can transmit Bluetooth to you Wi-Fi to عبيدة, okay, then it will be PAM for you or maybe FSK to him.
So you mean the phone itself, the Wi-Fi has different band than the Bluetooth?
Definitely. So everyone is a sequence, يعني is a train of symbols. فيعني maybe over Bluetooth I'm sending something else than over Wi-Fi.
I thought it's only one system.
No, because this is why this is the nice thing about the communication. So there can be several setups, okay, working in parallel. So I can make a phone call or download a video or receiving WhatsApp and so on, and everyone independent from the other. Answer?
Disadvantage for the car. It's affected by this.
You were not here. This was not last time. The one before. This was not the last lecture. The one before. This was a review, okay? But the one that you were missing is the whenever I explained it. Yes, you are welcome to the office hour. Okay, more questions? Okay, so let's make a small review. Fast review. So, different modulation schemes. We have PAM. Okay, with its advantages and disadvantages. Then we upgraded to have it at higher frequencies. Then we commented about the PPM. Whenever here it was about the position. Okay, we solved some issues. These ones. We had other issues. This one. Okay. But yeah, it is another scheme that can be used. We commented when it can be used. Okay. And yeah, I put here the example of the readers. Then we went to the FSK. Oh, well, I missed something. I will come back. So we went to the FSK. We said here we have it about frequency. So different symbols will have different frequency. Oh, good. So here we have it here, the figure. You see all of them with the same amplitude, but symbol 3 has a different frequency than symbol 4, different frequency than symbol 1. But yeah, it is. It does not have any synchronization problems. It is easy. Okay, so low complexity, same amplitude, same energy, same timing. Here, let me add. It is a low complexity setup. But the issue is that frequencies. Okay, so we could have 10 frequencies. No, they have 16 frequencies. Okay, but they could not be able to upgrade. So here, this is why 2G 2G was for voice or SMS. Whenever they wanted to have access to the internet, they said, sorry, you have to change the standard. So you need to go to something else. Okay, and then they had to change this FSK. And I see that we commented about the CRA. Anyone visited CRA yesterday? Not yet? Okay, good. So, what is for today? Another modulation family. Okay, again, not better, not worst. Okay, each one of them they have a different performance, and you as an engineer, you are the one who should say which one is suitable for your use case. Good. So here this stands for phase shift keying. So phase modulation. Okay, phase is the keyword. And here, how we will distinguish between the symbols by their phase. How is that? Well, first of all, this one will solve that they have same amplitude. they will have same frequency. So we don't have an issue with frequencies and CRA. They don't have here no synchronization problems. So this is the disadvantage of the PPM. But yeah, we know that there's nothing for free. Okay. So here, these three are good stuff. These are advantages. Let's see how it will work. Then I will tell you the disadvantage. So how it will work? It will distinguish between the samples in terms of the phase. Do you remember how you were calculating the phase whenever it was here real part or imaginary part? How? The angle. So here this was the angle. So whenever we say, so here this was the phase. So the way is that we will have it like this. So we have symbol 1, symbol 2, symbol 3, symbol 4, 5, 6, 7, 8. Here it is 8. Okay, so here this setup is called 8 PSK. 8 different symbols. How we will distinguish between them? How is their amplitude?
Same.
Why?
Because of the same vector.
Because yeah, it is a circle. This is why I drawn a circle, okay, and it is the radius. Okay, so same amplitude. Frequency, there's no frequency, okay, here. What else? No synchronization problem, no timing. Okay, it's only about phase. So we will say the phase for this one is 45 degrees. The phase for this one 135 degrees. Abu Hassan, you have a question? Good. No synchronization problems.
The samples should have the same sinusoids, yeah, in order to.
Same, so yeah, it's the same frequency, so same sinusoidal. So if I have here a sequence of samples, now write down, then I will talk. Attendance sheet 1. I have here your quizzes, so please remind me at the end of the lecture to show you the quizzes. يعني في من كل الاشكال والالوان. انت تبعتك مش كثير حلو.
انا صدق
مش I don't know. يلا I will know هلا كونكم انتم بتكتبوا انا زهقان. محمد صح؟ I properly remember it was a 7 بس يعني for out of 10 for curiosity صار على بالي اشوف. What is the key word in engineering? That. But yeah, I have so many 10s. 7.25. Oh, I forgot the attendance sheet. Okay. Done? Can we? Yeah. Okay. So, if I have a sequence of symbols to be transmitted, let's say S5, S1, S3, S7, S1, and so on. How they are transmitted? This is time. First symbol, second, third, fourth, fifth, and so on. So on the first one, it is S5. So we will send a signal with a phase of 180 degrees. You see here, this is S5. S1, 0 degrees. S3, 90 degrees. S7, 6, 7, 270 degrees. يم طلعوا كلهم هيك. S2 here. S1, 0 degrees. S2, 45 degrees. How we will send a signal with the phase shift?
Signal source, you mean?
لا يعني لا I don't know. You want to send a signal with the phase shift. How it will look like a signal with a phase shift?
شفت الفيرجن same amplitude same everything شفت الفيرجن
That's it. So here, if you remember, what's the difference between them? How much is the phase in A? In A 0? 90? طب in B?
cosine and cosine like plus 90 or minus
طب what is our reference? The sine ولا cosine? The cosine is the reference. طب 0 and 90. Okay, this is the phase shift. Okay, so here we don't have a phase shift. We have a phase shift of 90. So here we, yes.
B can be 90 or negative 90, right?
لا بس 90. Okay, so it has to be negative 90. It will have to be like this. Negative 90. Or if I want it to be minus 180, it will be like this. So this is 180. No? Ahmed? Yeah? فكر طيب good. This is 0. So the cosine starts from here. If I want, so here, this is the 360 to here. So if I want it to be 180, so this is why I will start from this point. So I will move this one to be from here. I will obtain this one. Good? If I want it to be 270, which is minus 90. We have a mistake here, guys. Yeah, Hamad, good. Thank you. Okay, so it is like this. You're right. Okay, then how much you shift? Yep. Okay, so here this will be, if you make the shift up to here, so 90. So here you are starting now with 90. If you are making a shift up to here, 270, which is minus 90. Good. Okay. I want to send now the signal 180. How I will do it? Okay. Then the next one 0. Then the next one 90. No, guys, I غلط هاي. Guys, you don't fix me my mistake. Okay, good. It has to be like this. Well, then 90 و 270 و 0 و 45 يعني تكون no 45 already cut some of it, so lost. Let me repeat. So here the first symbol, okay, was S5, okay, and S5 corresponds to 180 degrees. Then we will take the cosine that corresponds to 180 degrees. This is the one. Good. Then the next one is 0. Where is the one of 0? This one. Then the next one, it was S3. S3 is 90 degrees. What are the 90 degrees? The 90 degrees, this one. 270, this one. 0, this one again, and so on. Good. The signal is continuous. And if it is not continuous, here there will be a sharp change. But yeah, at the start of every symbol, okay, we need to know what is the phase shift. Hamad, what's up? Sure. Is there anything not clear? Abdullah. انت what? Is there anything not clear?
لا بس قاعد اتذكر الزواج.
Right. Good. Good so far. Okay. We have not seen the disadvantage yet, but I'm just explaining how it works. طيب يلا let's see the disadvantage. What do you think is the disadvantage for this scheme, عبد الغني? Well, we said it is equal amplitude. كيف يعني more power? Yusuf, what do you think is the disadvantage for the scheme? Do you see any problem in the scheme?
ممكن يكون accuracy بتاعته كتير عالية زي مثلا في error بسيط ممكن
How?
يعني إذا في خطأ بسيط مثلا ممكن
That's it. So here, if we have a noise, okay, so what we will have, okay, so here, imagine that here you send this one, but because of the noise, you receive it here. What the receiver will think? It will think that it is this one. Let me put an example. Okay, to make the example, let's make it much easier. Okay. This is 8 PSK. I will come. What are the other options? We have 4 PSK. How it will look like, the 4 PSK? Only 4. Like this or like this. So this one, I rotate it. Okay, so if I rotate it like how much? 45 degrees, I will obtain this one. Okay, so here, circle, or here, circle. Same circle, okay, but just rotated, okay? And between them, it's still 90 degrees. So you see here, still 90 degrees. It is just a rotation. I guess we did nothing. Yeah, but sometimes people like this one more. Okay, it will help us in the analysis of the error probability. Okay, next chapter. But yeah, so this is the reason why this 4 PSK is called by engineers, it's called QPSK. The Q stands for quadrature. Do you know what is a quadrature? Batrani. Hisham. This is a quadrature. The crossing of axes. So here, all of this is a quadrature. So because this scheme has only one symbol in each quadrature, they call it the quadrature PSK, QPSK. Okay? It is one of the most used modulations, okay, in life, this QPSK. Fine. Can we make it less than QPSK? What? Yeah. So these are 4. Okay, if I want to have it less than 4, which will be the number? 8 is more than 4, guys. 2. Okay, so here we have 2. It's called binary PSK, which is 2 PSK, but yeah, no one call it 2 PSK. It is binary PSK. How it will be? Only one here, or one here, or one here, one here. Good? So I have 2 symbols. Does it remind you about something that we have seen already? In modulation, yes. About what? This modulation, does it remind you about another modulation that you have already seen?
Position?
هاي إلها دخل position. Come on, what is the position here? That's it. So here, this is exactly the same as binary PAM. Let me remind you. In binary PAM, what we used to do, we said that here we put the 0, and here we put the different symbols. Good? If we take only 2, we will end up with this, which is exactly the same. In PAM, they were saying that the difference between the symbols is that here we have an amplitude, here we have another one. And someone, he said, how it will be negative energy or a negative power, I remember, right? I told you that here distance and here distance, okay? So here they will refer to this as positive energy and here as negative, as negative. Even there is nothing called negative energy, but just to reflect, this is the distance as a negative. Do you remember? Okay, good. So here they were distinguishing between the symbols in terms of the distance. Here they are distinguishing between the two symbols in terms of the phase. So here they're saying this is 0 phase, with this one 180 degrees phase. But yeah, they are the same, two symbols. Hamad.
كنت ادور على الزاوية يعني
طيب.
بس رجع. الحين اكيد هذا النيجاتيف 90 صح؟ الحين احس غلط احس عكس 90 ونيجاتيف 90.
This one? يمكن. Double check. Okay, because I'm used to write it before like this, but you now I'm thinking about it. I thought it's not minus 90, but maybe it's a mistake. Good so far. So here this binary PSK is exactly as the binary PAM. Okay. Let's see why this one is interesting, and whenever we will see this one, we will understand what is the disadvantage for this scheme. So imagine here, this is two symbols, S1 or S2. Okay, so imagine my sequence to transmit is S2, S2, S1, S2, S2, S1, S1, and so on. Then how I will send it? So here it will be 180 degrees, 180 degrees, 0, 180 degrees, 180 degrees, 0 degrees, 0 degrees, and so on. Good? This is what is transmitted. What is received, because of the noise and interference, imagine it is like this. 172, 191, minus 7 degrees, 125 degrees, 200 and how much you want? 14 degrees, 25 degrees, 47 degrees. This is what is received. Do we have any symbol that has a phase of minus 7? We here the system agreed, transfer receiver, that it is binary PSK. So it is either symbol 1 or symbol 2. Okay, but here the receiver, this is what the receiver receives. What the receiver will do? What? Yeah, so it will approximate. So here it will say, I received 172. What does it look like? S1 or S2? Because it knows that only S1 can be sent or S2 can be sent. يعني receiver or transmitter, they agreed that the modulation is BPSK. So it knows the receiver, and I will receive even S1 or S2. I received 172. What does it look like to be? S2. So here it will fix it to be S2. This is 180 degrees. Then the next one, it receives 191. Again, it will say it is closer to 180. Then it receives minus 7, closer to 0. So S1. 125, closer to S2. And the same, S2, S1, S1. Comparing whatever has been what we want to transmit, and here decided at receiver. Are they the same?
Yes.
So what you can conclude? That's it. So here, BPSK can easily compensate or fix noise plus interference problems. Officially, it could be said BPSK is, what is the word? Robust to noise plus interference. Which application we have seen that you have to be robust? Even there is some error, the system should not have errors. No? Again? No. That's it, banking. So here, this is why this is the one you used in online banking. Yes.
Robust what?
Robust to noise and interference. Robust means يعني it can fix. It is not affected. This is the meaning of robust. Okay, in engineering, whenever we say this is a robust design, it means it can be hit and still work. Okay, it can receive noise and still work. Receive interference, still work. Solid. وين خالد؟ The three of them. تمام. حط هون attendance sheet. خالد.
دكتور خالدين يعني
3 خواليد.
عندهم مشروع بعد بكره يروحون الامارات مع الجامعه قاعد يخلصون.
دبل اذا هيك حط لهم 2 times missing. Sorry. And interference problems. Good so far? Imagine questions. Questions, Muhammad, Abdullah. All good? Hisham.
So here, like this one, we only use it if we have two samples. Right?
That's it. If you have 2 symbols, yes.
Symbols, like binary,
Hmm.
0 or 1.
Hmm.
Any other things we cannot use this.
That we can. So here you have a sequence of data. And do you remember what was the main role for modulation? Why we need modulation? Whenever we started with the modulation, what was the objective of modulation? Combine bits into symbols. Okay, so here the combination is stupid. Okay, it will be 1 to 1. So here this will be S1, this is S2, 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 S1, 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 S2, and so on. So in other words, this BPSK is straightforward. Okay, we are not gaining anything from the modulation. When we will gain from the modulation, when we can group 2 bits or 3 bits or 10 bits together into one symbol, we will gain from the modulation. But yeah, so here BPSK is very robust, and this is why it's used in online banking. But then what happens with its data rate? Low, slow. So here the data rate, it is low data rate. Why it is low data rate? Here every symbol is 1 bit. In the other ones, every symbol is 10 bits, 10 times the data rate. Okay, you can download 10 times faster. You will receive the same number of symbols, but each symbol will correspond to 1 bit, like here, or will correspond to 10, like in other one. So on the other one, you will feel it 10 times faster. Okay, so the data rate for this one is low, and actually this is a link. Online banking application is always low, low speed. Good.
So this could be the disadvantage, yeah?
This could be the disadvantage. Listen, no. But this is BPSK. Okay. Let me compare. Imagine that whatever it was sent was QPSK. Or better than QPSK. 8PSK. So here we have seen BPSK, QPSK, 8PSK. So if I want to compare 8PSK versus BPSK, what you will say? BPSK versus 8PSK. So here, in terms of data rate, this will be lower, this will be higher, right? So here it will be 8. So it means 3 bits. So we have 8 options. So 3 bits in each one of the options. Why I know it is 3 bits? Yeah. So here, if I have 8 options, okay, 8 PSK, so I will make them 0, 0, 0. This is for the first option. For the second option, 0, 0, 1. Until S8. Good. So here the data rate, it's 3 times. I can say it roughly. So here, this is the data rate is multiplying 3. Because now in each symbol, I have 3 bits instead of 1. Good. But what will be the disadvantage? There is nothing for free. In engineering, alhamdulillah, there is nothing for free. So what will be the disadvantage of the 8PSK compared to the BPSK?
It's
Yusuf.
hard to predict. It's harder to predict maybe it's between two angles.
And what will happen?
It will maybe choose one of them. Maybe it's one.
That's it. So here, the error probability, here it will be larger. Okay, here less. This is good. This is bad. So the VPSK, its probability of error will be large. Why? As your colleague said, maybe as with a small shift in the angle because of the noise and error and interference, then I will make a mistake. And this is the reason why there is no 16 PSK. 16 PSK does not exist in a commercial system.
What's
QPSK, it is this one. Where is it? This is the quadrature. So it is the 4 PSK. 4 PSK, its name is QPSK. Yani I could have written 2 PSK, 4 PSK, 8 PSK, but instead of that, this is called binary, or this is called the quadrature, or this has no name, as it is.
I don't understand why it's lower in your probability.
Why it is lower? Okay. Okay, and compared to this one. So this is VPSK and this is 8 PSK. Good. Imagine that what I want to transmit is, and let me change the color, this symbol. This is what is transmitted, this is what's transmitted. Good. Now what is received because of the noise and the error, it is this one. What color can I write? Blue. So what is received is this one. Imagine that what you receive is the blue one. Good. Here, whenever you are in BPSK, can you guess what has been sent? You will say, this one is closer than this one, so definitely it is this one. You fixed, you compensated for the noise and interference, and you were successful to receive. Whenever now it is this one, can you guess what has been transmitted? You will think it is this one because it is closer than this one. You will make a mistake. Clear? So this is why here the probability of error is larger than this one. Clear to all? Sure? No questions? Khalid. Osama not here, right? Omar not here, right? Who else? Saeed. في أنا Saeed? No, we don't have Saeed. Hisham. صالح ولا صلاح؟ صلاح هذاك صالح missing. شهاب.
What are the applications for APSK?
8 PSK isn't the standard. Okay, so it is intermediate because now I will see other ones that they have more probability of error. So the standard will give you the options. Okay, how much each one? So they will give you like 7 options, and based on what is the probability of error that you want, you will fix your stuff to whatever you need. The least one is BPSK, but there are other options.
I mean, is there anything practical in our world that we use that uses APSK?
8 PSK, this one actually uses 8 PSK. Okay, so the 3 of them, this one uses 8 PSK or BPSK with QPSK. So whenever you connect to the internet and you feel it slow, most probably it is using this or this. A bit faster, this one. A bit faster, this is the next one. No, there is another one. Good so far? So 16 PSK, as I said here, where I wrote it, and والله كتبتها. Yeah, here, yeah, and it is not implemented. Okay, they have found that its probability of error is large, so they needed to compensate by another way. This is why here we have a new section or new modulation. It's called QAM modulation. QAM stands for quadrature amplitude modulation. This is a hybrid one, okay? It is between the quadrature, so it is PSK, and the amplitude, it is PAM. So here they are adding PSK plus PAM, okay? It is merging between PSK and PAM. And for this one, we will have 16 QAM, 32 QAM, 64, 128, 256, 512 QAM. In theory, we have up to whatever number, okay? But all of them, what is common between all of them? 16, 32, 64, 128. 2 to power something, okay? So all of them, they are 2 to the power something. Why? Just like this, okay? So if you make 50 QIM, it is a stupid proposal. Why? Because it will not reach the 64, so it will have to stick like 32, but having better, worse performance in terms of error. Let me repeat. So imagine that will tell you, we have a new one, 50 QIM, but bad one. Why? Because its data rate, it will not reach this one. We don't have enough number of symbols, okay? So it will be exact data rate as this one, but it will have more error probability than this one. Clear? So here it's like whenever I have BPSK or 8 PSK. So if I have here 7 PSK, it is a stupid approach. Why? Its data rate, it is the one that is less than 8. It is equal to the QPSK data rate, but the error, it will be more. So it will not reach the data rate of this one, but it will increase the error. So I'm gaining nothing with this proposal. Good? So there are actually a question in the book. It's saying, what would you say about a proposal of 100 QAM? Why? Because the data rate is not increased in comparison to 64. So it is the same data rate. Let me write it here. So a 100 QAM proposal. It's a bad one. Why? Because data rate exactly the same as the 64 QAM. But more error rate than 64 QAM. So what are you gaining? Okay. If you go to 128, I will understand. It is more data rate or more error. لا حول ولا قوة. Good. There's a trade-off. But here, this one, it is only more error or no gain in data rate. This is why it's a bad proposal. Clear? So here, this one is it's a non-engineering. Okay, it is a bad proposal. Good, ya Abdul Ghani. Ahmed Faiz. Okay, so let's see, understand this, what this QAM works. Okay, so they said let's put here 4 symbols. Okay, then because it is a merge of PSK or PAM, so different amplitudes. So different amplitude means we have another circle. And this another circle, I can put 8. Another circle. And this another circle, I will put 4. This way, I will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is the plot for the 16 QIM. I want to do a 32. What should I do? A couple of more circuits, okay? 2, no, maybe 3. No, just wait. 20, 28. Yeah, 2 more. 2 more circles will fit. Good. I want to do it 1024. Continue with the circles, okay? Each time, because here, from this, what we call it, this is, let's say, this is symbol 1, or this is symbol 6, let's say. 1, 2, 3, 4, 5, 6. Yeah, it could be. Okay, so What is the difference between them? Do they have the same amplitude? Why?
Because not the same real point.
No,
The radian.
distance. So we know energy of distance. So here, this distance is not the same as this distance. Good. So here, different distance means different amplitudes. PAM, this is the idea of PAM. Okay. Do they have the same angle? No, here or مكان. Okay, but yeah, here these two, yes, they will have the same angle. Okay, but they will have the same amplitude. That's it. So here we will distinguish between the symbols, even amplitude or phase. This is why it is a hybrid scheme called QAM. Okay, it will merge between PSK and PAM. Advantage for this system, yeah, here the data rate, here advantage. The data rate is boosting, jumping, okay? Each time we increase by 100, okay? And go ahead, good? So the advantage here in terms of data rate. Disadvantage, definitely more error. Because why? Here you have more symbols, okay? So the probability of making a mistake is larger. What else? It's not only error. Do you think it's easier to implement? So here it's also more complex. But yeah, we are crazy about data rate. Always we need more data rate. 50 megabit per second, 100 megabit per second, okay? This is why it was pushed into the standard, okay? And now on the standard, they have up to this one, or maybe more in the future. Cool. So here, the idea of the QAM is the difference between this one and the FSK, for example. FSK was good, but it was not upgradable. Okay, so cannot be made more because there were no frequencies. But this one, yes, it can be made more. Okay, it will be more complexity. How you will solve the complexity, Ubaida?
Solving the complexity, make it more simple.
Increase the processor.
That's it. You increase the processor speed. Yeah, but the phone now is better than the phone 6 months ago. Or after 6 months, it will be more powerful than current phone, and so on. By the way, every time they release a new phone, okay, even if you have a Samsung S whatever, how much now is S14 they have reached? S22? Ah, yes, for sure. I don't know. Okay, so iPhones, yeah, 14 iPhone. Okay, good. So every time, yes, it is fancier, will screen better, but also it has a better processor. So there is a part of marketing, let's say, to attract people to buy it, but also there is a part of engineering. Cool.
ممكن شيء engineering ولا
No. يعني you will survive with a less resolution screen. You will. Have you checked the resolution and the last phone that you bought? No, but yeah, they are, whenever it will tell you, oh, this phone has a 50 MB camera. Wow, you will buy it. But then after that, whenever you want to send it over WhatsApp, they will reduce it to half a meg, right? But yeah, so what is the purpose? Because, well, I like it. Or because, well, let me take a picture here, a picture, but then you will say them, you will never see them. So yeah, there is a high component of marketing, okay, to attract people to buy. Yeah, definitely. The interference is issue. This is why it can induce error. Cool. This system is equal energy.
No, not equal distance.
That's it. So here, not equal distance, not equal energy. What will happen with the power amplifier? Yeah, it will. The power amplifier will suffer. Okay, because the value will always change. Okay, And most probably we will have to buy an expensive power amplifier that has its linear range is wide enough to support all of them. Okay, good question. Is it possible to obtain the average energy? Average energy? I know it is not equal energy, but can you tell me the average? That's it. So here you will add each one of them and you will divide. Let's do it. Let's put them here. Yani more formal. Distance here D, 3D, D, 3D, minus D, minus 3D, minus D, minus 3D. Good. So this one we call it what? S1 again, all right? S1, S6. So here, this S1. How much is the energy for S1, yeah, Mr. Muhammad Noor? Mish approximately. I want the exact one. How much is the energy for S1? What?
Can we consider it like 1 watt?
Calculate the energy based on this figure, ya Muhammad Noor. How much is the energy? No. Ahmed Faiz.
Distance square, I think
Distance square. So we know that energy equals distance square, right? So how much is this distance, yeah, Ahmed Faiz?
square root of d square plus d square.
Okay, good. So this distance, so what you want to call it, x? So this x equals, as your colleague said, Pythagoras, d square plus d square under the square root. This one, it's a triangle. So here, this is d, well, this is d, so it will be under the square root. So here, x equals square root of 2d square. Our energy is the distance square. So it will be the x square. So how much it will be? Do the square with the square root, we will cancel each other. So here, the energy of ES1 equals 2d square. Do you agree? Lost? Abdullah? Lost? شكلك lost. Do you want me to repeat?
No.
Do you want me to repeat?
No.
Sure.
Why the square root Marshall square?
Okay, good. So here, Pythagoras says that this distance equals the square the square of this plus the square of this. So here, this is d, but this is d. Okay, this x is equal to the square root of d square plus d square. The square root of 2d square. Good. The energy is the distance square. And it is the distance, which is this one, the x square. So we want x square. So this will be square root of 2d square and all squared. So the square root will square. They will cancel each other. It remains 2d square. This is what I wrote. Clear? Batarani. All clear? Yusuf. Abdullah. Sure? Okay. This is for S1. Let's see what's next. What I call it. X6. No, S6 here. S6. For the energy of S6. So here, energy of S. Should I do the energy for S2? Why? So here, the energy for S1, O2, O3, O4 is the same distance. Good. So energy for 1, O2, O3, O4 the same. This is now here S6. How much is the energy for S6?
D square plus 6 plus 1 d square.
Okay, good. How to do it? So here, the energy for this one, it will be good. For the S6, it will be, it is here like a triangle. A triangle like this. And this distance will be again Pythagoras. How much is here? D. How much is here? 3D. There's the energy. Let's see here what you want to call it. X. So here, this X in black now equals square root of d square plus 3d square. So this is equal to d square plus 9d square. This is equal to 10d square. Now its energy, square of this one, so it will cancel the square root. So it will be 10d square. Clear? Ali, lost? حذيفة, sure? Muhammad.
In this case, doctor, we just have to calculate the energy for one quadrant, but then we can multiply by 4. So
No. Let's see. So here, who has the same energy as this one? 1, 2, 3, 4, they have the no. This one, or this one, or this one is they are different. So this one will be has the same as this one. So what they have to be? So here it is D with 3D. This one is 3D with D. Good. Or this one, what we call it S7, it has D with 3D. Good. Or this one S8, D with 3. But this one, no, this one not. We will come to it now. Okay. This one S9, D with 3D. This one S10, S11, S12. These four, they have a different energy because they are 3D with 3D. Now we will calculate. Cool. So we have here the energy for S1 or S2 or S3 or S4 the same. For S5 up to S12 the same. Now let's see, this let's call this one S13 and let me change the color to red. So for S13, write down, I will talk later. Can we? I was thinking to switch to slides. والله. What do you think? Hamad.
انا افضل بس ما اعرفهم.
لا كذا احسن خليك.
Like you breathe it.
لا يعني أنا عندي slides يعني to share with you the slides and explain on the slides.
depends on the slides. Can we see the slides?
اي صح depends on the slide.
حلو depends on the slides. Okay,
Slides
good.
are good, yes.
Okay, good. I will think about it. Good so far? Can we? Hisham, can we? Okay, so 12. So this is S13 now. And let me clean. How much is the energy for S13? So it will be one راحت عادلها قراءات. Okay. So one like this and the other like this. Okay, good. And now changing to red. Okay. So here this distance will be this one squared plus this one squared under the square root and then squared. So here that will be, and this now in red, this x will be equal to 3d squared plus 3d squared. So this will be equal to 9d squared plus 9d squared. So this will be 18d squared. And our energy is the square of this x. So the energy of S13 equals 18d squared. Or here S13, 14, 15, up to S16, all of these, they have the same energy. Cool? Okay. Now, how much is the average energy? And for that, حمد يلا اوكي اد
15 دي سكوير.
Divide by all of them.
ما هو انت قلت 3 فانا يا
2d square plus 2d square plus 2d square.
ده اخترعوا شيء اسمه المالتيبليكيشن
صح.
اه
السكوير
4 multiplying 2d square plus the other one here it has 8 1 2 3 4 5 6 7 8 plus 8 multiplying 10d square plus for the last one for the last one 4 multiplying 18d square all of them divided by 16 this is 8d square plus 80d square plus 2 7 72d square. This is equal to 88 oh 160d square. Well, good, nice, over 16. This is equal to 10d square. This is the average. Let me give you a hint for the midterm exam. ده بطل لك بس هان. Okay. طب yeah, write down then I will give you the hint.
Professor, what is the reason of finding the average?
Okay. I can come to it later, but I can tell you from now that if you want to normalize the system, you want to make its average energy to be equal to 1. How you will do it? And how much is this D in a design? You want to design D. How much your D? You will put 2, so 2 centimeters, or 3 centimeters, or 100, or how much the D? So maybe I will tell you, make the average energy for the system to be equal to 1. So you will say, this is the average energy, then 10 D square equals to 1, then D equals 1 over 10 under the square root. This will guarantee that the average energy equals to 1, normalized. Good question, والله ما خطرت على بالي. Good. I told you I will give you a hint. Okay, so on the midterm exam, I can tell you from now that I will give you a question that you have to calculate the average energy. But then it will be some kind of strange يعني, shape. Maybe like this. Can you calculate the average energy? خلاص.
Only this question of the midterm.
One of the questions. Well, it will not be like this, but يعني similar to. So I will give you definitely يعني, I don't think I will give you the 32, but يعني, I will modify something. So I check how you calculate the average energy.
This is the last lecture before the midterm.
Yes. Today I realized this. Yeah, next week we have off, right? And the week after, it was on no, I will cancel the quiz. Okay, so it was on Wednesday, right? Yeah, so I cannot explain new material on Monday and ask about it on Wednesday. So the midterm will stop by this lecture. Today will be the last lecture included in the midterm.
You're going to cancel the quiz?
No, we will not make a quiz just after you come back.
Second question. Second question.
تعين midterm يوم الأربعاء مش الجاي اللي بعده. You will see that. And on the day of the exam there will be no lecture. I don't assume إنه يعني you will be able to understand يعني anything new.
Exam how long?
1 hour and a half. ممكن يكون فيك. I can make a lecture then the exam. Do you want that? شكله you want. Not the exam is not in the lecture time. 12:30 to 2. Ah, this is why you have this. Okay, good. Yeah, I have not sent you the place right now. Yeah. Mm. The bad thing about it is it is in B05. لا, I want something here. Okay, فأم
الطاولات هناك احسن.
طاولات هناك أحسن.
خوارزم ترى من
والله معك حق, في خايسة.
والله
Well, يعني you prefer the B05? خلاص, it will be there. يعني I thought that you want something here, but يعني I have already reserved in B05, so I will send you the room then. شو ماله؟ Yes. طيب خلاص, good. ولا تزعل. Questions? Sure. What? This one لا خلاص بكفي. Good. So the midterm. No questions? طيب we stop here.